Good evening. My name is Vargas, and for my final project, I got assigned to select a significant construction project that was completed between the 1400s and the 1600s. And for my topic, I chose the St. Peter's Basilica. Today, I'll be comparing the construction of St. Peter's Basilica, one of the most iconic buildings of the Renaissance, with how it might be built today in 2025. The construction of St. Peter's Basilica began in 1506 and continued for over a century, symbolizing both religious devotion and cultural rebirth of the Renaissance. It reflected the Catholic Church's desire to assert spiritual and political power through monumental architecture. The design, influenced by architects like Bramante, Michelangelo, and Bernini, embodied ideas of symmetry, proportion, and divine order, key aspects of the Renaissance humanism. Structurally, the basilica needed to withstand massive vertical and lateral forces. The central dome, designed by Michelangelo, spans over 130 feet in diameter and weighs thousands of tons. The structure had to resist gravity loads, wind forces, and lateral thrust from the dome's curvature. To handle this, engineers relied on thick masonry walls, buttressing, and iron chains embedded within the stone to counteract outward pressure. During the 1500s, the basilica was built almost entirely by hand labor. Stone blocks were carried nearby and transported by horse-drawn carts and river barges. Cranes powered by human or animal treadmills lifted materials hundreds of feet into the air. Builders used wooden scaffolding and falsework to shape the massive arch and dome. The dome itself required a complex wooden centering system, a temporary framework that held each brick in place until the structure could support itself. This process required enormous amounts of time, skill, and coordination, relying heavily on craftspeople, masons, and artisans. If St. Peter's Basilica were built today, the process would look dramatically different. Modern builders would use reinforced concrete and structural steel instead of solid masonry. The dome could be prefabricated in sections and assembled with tower cranes or even 3D printed formwork. Falsework would likely be modular steel scaffolding with laser alignment system, dramatically improving precision and safety. The transportation materials would involve heavy trucks, cranes, and GPS-tracked logistics. Digital tools like building information modeling would allow engineers to simulate loads, detect clashes, and ensure structural stability long before construction began. So, earlier dome failures such as